in no way, shape, or form one maze.
Oh, it's close enough. How about this? It'll be one maze physics. Yeah. I kind of get to vote. Yeah.
What?
That's,
Well, if you get a vote, they should get a vote too.
no.
What?
This is not a democracy. Let's just get this straight right now. That ship sailed a long time ago. Okay? I'm just telling you.
Can we at least pretend?
No. Nope, I'm not even gonna let you have that illusion like your vote matters. I'm just saying I'm old and cranky and it's Monday morning, so there you go. Okay, so, so let's talk about, it might be a democracy in May South, but it's not. All right, so let's talk about the lab and the different aspects of what you all have going on. So, you took a spring, you hung on some weights from it, and you measured how far it stretched, and you got some nice data points, and you have a line that looks something like this, and you should have it neatly labeled. Here's the elongation in meters, okay? So here's a couple of things that I'm going to look for, okay? One of the most important skills that you have to have is just, and you wouldn't think it's that complicated, but it's just the ability to just follow instructions, okay? Because when you get out in the real world and your boss says, hey, this is how I want it done, and you don't do it that way, it's like, it's true. It's like if your boss can't trust you with small things, they're not going to trust you with big things, okay? Literally, you want to be successful in life, you have to just be about 10% better than the competition. That's it. You don't have to be 100% better. You just have to be about 10%. And a lot of that just boils down to, do you care? And if you care and you do a good job, that's going to go a long way. All right. So here's the deal. So I should see this. The other thing I should see is a couple of data points that you used that are actually on the line of best fit, okay? You can't use your data points if they aren't on the line of best fit. That was the whole point of drawing the line of best fit, okay? So I should clearly see that. Somewhere, either here or on the sheet itself, I should see the calculations of slope. Now, Danny, in what form are you not going to leave your slope?
In a fraction.
As a fraction. Spot on answer. Okay? All right? I don't like fractions. I know mathematically, I know the argument. It's a more exact answer. I don't care. Okay? Not decimals. So, depending upon which spring you have, your slope should probably be something around 0.0 something. Okay? For that first slope. Now, what else should you have beside a numeric answer?
The unit.
The units. Here's the other leap of faith that you have to have when you start defining slope in a physics class. You all were used to, up to this point in your lives, of just slope is just a number. That's all. That's all it's ever been. It's just been a number. So you got to shift this mindset that says, ooh, if I put units on it, now I know what that slope actually means. So, Danny, what did you get for your units on your slope on that first one?
0.167 meters per kilogram. No.
Meters is right. And here's the reason why. You plotted force and elongation. Right? Hopefully.
No, I did it by mass. That first one. Damn.
I have no idea what this is. Okay.
Is that just a random
It has
pass?
my name on it. It's just literally, it is a green piece of paper. Oh, just hall pass. Boom, there you go. Is that for me or for my class? I don't know. Okay. So this is going to play out large later on. we plotted force and elongation. This is why when you had, let's say for example, you used a 1 kilogram mass and you multiplied that by 9.8 meters per second squared, okay? Then when you do that, when you multiply mass by your acceleration and you get units of newtons, this is what you plotted along that x-axis. Okay, so hopefully you plotted that FG column, okay? Because that's why I've got up here on the front where it says we're going to plot the relationship between force and the elongation, okay? If we were to do mass and elongation, then your units would be right. It would be mass, be meters over kilograms,
Okay.
okay? But we got to do that force column,
Okay.
okay? So anyway, so you should end up with units of meters per newton. Now, here's the first thing I'm going to do, okay? When I get Will's lab, here's the first thing I'm going to do when I get that first graph. I'm going to tell you straight up. I'm going to come over here to that 1 Newton mark, and I'm going to come up here, and I'm going to see where that crosses that line of best fit. And that should be about what his slope is, okay? Because that's what that number means. This is how far it stretches per applied Newton of force. So go to your graph, find the 1 Newton mark, come up here, see where it crosses at 1 Newton, and see if that's about where your slope is. If it is, odds are you did it right. If it's not, something went horribly wrong, okay? Cool with that. So I should see your slope, make sure you have the units, make sure I see how that number's been calculated. Cool with that. Okay. Now, when you get to number 4, when I said write the general equation of the line. So it's y-intercept, y equals mx plus b. You have to worry about the y-intercept part of this. And do I have to worry about the y-intercept part of this? Why not? Yeah, okay, there is no y-intercept, okay? Because if I don't apply a force, guess what?
No,
I don't
that
have
is-
any elongation, okay? Now, notice on here, I've got including the units for the slope. So there's a couple ways you could do this. You could write this as elongation equals your slope, maybe 0.0 something meters per Newton times your force. Okay, so if you want to put it in terms of what you actually graphed, you can do this. If you just want to write it as y equals that slope times x, you can do that. Okay? I don't care. It makes me no difference. Now, here's the whole point. On number 5, where it says, using your equation, determine the force required to produce an elongation of 15 centimeters. So, this is why you pay attention to the units. So you come over here and go, okay, hey, my elongation is 15 centimeters. Are you going to leave it as 15 centimeters?
No.
No, you got to convert that into meters. This is why you pay attention to the units. And this is where the magic happens. No, it's magic. But this is what we're going to talk about today in terms of dimensional analysis. You're going to take 0.015 meters, and you're going to divide that by the slope of meters per Newton. Okay? It isn't just a pure mathematical operation. Pay attention to what happens with the units. Oh, I've got meters divided by meters per Newton, which is the same thing as taking meters and multiplying it by the reciprocal of newtons over meters in terms of the units. Oh, that's cool. The meters cancel out. I'm left with newtons. That's what that force is measured in. Okay? So again, the sooner you embrace this idea of saying, hey, you know, is this just a number or is there meaning to it? The sooner you make that leap of faith, that's going to help. Now, here's the other thing that you can do. You have a certain value that corresponds to 0.15 meters. Little self-check you can do. Come up here to your elongation, see if you can find like where 0.15 meters is on that graph, and then come across here and see if that kind of matches up with what's on your graph. Okay? If those, and basically all you're finding is an x and y coordinate system. That's it. Okay, that we call meters and newtons. It's just x and y. So go to that 0.15, go across, see if your answer kind of matches up with that point on the graph. If it's close, hey, you're okay. If it's not, something's a train wreck. Okay? Cool with that. Good so far. Okay. Now, let's talk about how I want number 8 answered. Because you guys are going to be answering a lot of like, what if we change this? What if we double the mass? What if we increase the radius of the Earth's orbit? What if we double the mass of the satellite? Okay? Play a lot of hypothetical what if questions. So a handy way to answer these questions is this phrase for a given. So here's what you don't want to do. Okay? Here's what you don't want to answer this. Don't answer like this. Say, well, if there's a heavier spring with more mass, there's more elongation. Okay? That's true no matter what. More mass you put on anything, the more elongation that you're going to get. It's not the point of the story. Another thing, and I've noticed this maybe in the last 5-6 years, and I think somewhere there's been a change in the philosophy of the teaching of the lower grades. Like, you feel the urge to like restate my question, okay? Like, I don't know if y'all have been taught, stop, it's annoying, okay? I wrote the questions. I know what the questions are. You don't have to tell me what the question is, okay? Stop. It's a waste of your time and it's a waste of my time to read it, okay? Do not, in this class, once you cross the threshold of that door, okay? I don't care what other teachers are going to do. I'm just telling you. I wrote the question. I know what the question is. Don't restate the question, okay? I know what the question is. Does that make you happy?
Very unbelievably happy.
Okay, that's all it took?
It's gonna take. Yeah.
Okay. I'm just telling, and it was just weird. Like, it literally started like 5 or 6 years ago.
I've
What's going on?
I've been told since like first grade, second grade. Like as soon as you're writing out answers to questions, restate the question before you answer it.
No, don't. Whoever came up with that didn't have to read a bunch of papers. I promise you that.
Of
Or at
course,
least they
that's-
didn't write the questions.
That's
So-
like the entirety of like curriculum.
Okay,
people.
anyway. Don't restate the question. If you've already
Gladly.
done it, don't worry about it. But,
Most relatable teacher.
okay. All right, so here's the story. Let me give you an example of how you can answer this question. Pick one of the variables and hold it constant. Okay, so imagine that we've got this big massive coil spring. Okay, big massive coil spring. So here's the approach that you can take. Either keep the force constant and look at the impact on the elongation, or keep the elongation constant and see what happens to the force. Okay, those are the two approaches you can take. Don't change both of them. Okay, that's why I said, so here's one option that you can do. You can say, for a given amount of force, okay, and you don't have to specify what that force is. You can just say, for a given amount of force. So in other words, I'm going to come out here and I'm going to apply a given amount of 10 newtons. Okay, I'm going to apply a given amount of force. So at that point, I'm going to apply the same force to this big, massive, heavy coil spring. One of three things is going to happen. It's either going to stretch more, it's going to stretch less, or it's just going to be the exact same. Okay, those are your three options. So if I apply a 10 Newton force to this big, massive, heavy spring, it's either going to stretch more, stretch less, or it's going to be the exact same. So what's going to happen? Preston, what's going to happen?
But it's going to stretch less.
So what's going to happen to the slope?
It's going to have less of a slope. Oh.
Yeah, there you go. So if I apply that same force of 10 newtons to a heavier spring, there will be less elongation, therefore the slope will be flat. Okay, something like that. Okay? Now you say, oh, Mr. Burkham, I like elongation. Well, I'm happy for you. Good for you. Okay? So I was president of the elongation club in high school. Fantastic. So the other thing you could say is like, hey, I want a given elongation. I want this spring to stretch 10 centimeters. Pick a number. If it's a heavier spring and I want the same elongation, that's going to take more force. Therefore, the line's gonna become flatter. Okay? So that's why I said, when you answer a question like that, pick one. Either pick force and see what happens to elongation and the impact on slope. Pick elongation, see what happens to the force, see what happens to the slope. Okay? Cool with that. All right. All right, so now let's talk about number 9. There's 3 options on number 9. So we're gonna go to the moon, ultimate field trip, and we're gonna do this lab on the moon. Okay? Cool. So 3 things can happen on your answer to number 9. The line is more steep, the line is less steep, or the line is exactly the same slope. Okay, those are your 3 options. So let's do a quick opinion poll. How many of you say that the slope is going to be more steep? Okay, nobody's on the more steep train. How about the line's going to be less steep? 1, 2, 3, 4. Okay. Line's going to be the exact same. Danny, did you vote?
No, I did the last one.
Oh, okay, all right. Okay, so let's talk about this. Let's talk about this.
What's remaining constant, the force or the mass?
Just hold on. Hold on. Hold on. Just show up. Keep in mind, what did you plot on the graph?
Force.
Go to that idea. What did you plot on the graph? Mass and elongation or
No.
force and elongation?
Force and elongation.
You plotted force and elongation. Okay? You plotted force and elongation. Now, let's just say that instead of using mass to pull down the spring, you just pulled your hand, okay? And so let's say you're on Earth, you take that spring, you pull down, it takes a certain amount of force to pull the string to a certain distance, okay? Now, you go to the moon. You use your hand again. Is your hand going to take the exact same amount of force to stretch it the exact same amount on the moon?
Yes.
Because it's force and elongation. Okay? It's force and elongation. Now, you take a 1 kilogram mass to the moon. Instead of using 9.8 meters per second squared, we're going to use 1.5. So that 1 kilogram mass on the moon is only going to weigh 1.5 newtons. Okay? So, if I take that 1 kilogram mass and I hook it up to the spring, is it still going to stretch the spring? Yeah. Is it going to stretch it as far?
No.
No. Why?
Because it weighs less.
There's less force, right? So, because it's force and elongation, okay, what would happen is that your data points would be really, really close together. Because let's say the maximum amount of mass you put on there was 1 kilogram. Okay, well that's only going to go up to 1.5 newtons. Whereas if you use a 1 kilogram mass on Earth, it's going to go up to 9.8 newtons. Okay, so it would still stretch. This wouldn't stretch as far. Now here's the kicker. So Danny got that slope of 0.01 something meters per newton. Okay? Understand what the slope represents. That's how much force it takes to stretch it per meter. If you're on the moon, is it still going to take the same amount of force to stretch it that same distance? Yes. So therefore the slope is
Unchanged.
not changed. Okay? Now, if you need to change your answer, change your answer. Okay? But this is like, oh, you got it wrong, you can't change it. Okay? If you don't have that answer, fix it. This is why I have you all write in pencil and not pen. Because there's a very little secret. It's easier for me to grade papers that are right than papers that are wrong. I don't have to yell and scream and have an aneurysm. Are we cool with that? We're good. Okay. So let's move on to the backside of this. So the first graph that you drew, you put force on the x-axis and elongation on the y-axis because you have two variables. You have force and elongation. Force is your independent variable. Elongation was your dependent variable. That's why we drew it that way. Now, and this will make sense once we get into energy, okay? When you stretch a spring, you store energy. There's two broad classifications of energy. There's potential energy and kinetic energy. Kinetic energy is the energy of motion. Potential energy is stored. Like if I lift something up, I store potential energy, okay? So cool. Now, to make the units work out for energy, when you draw this graph, and like I said, in December when we do this graph, this will make more sense. I'm just kind of laying the groundwork right now. On an energy perspective, we need to put force on the y-axis and elongation on the x-axis. So again, here's what I should see. You should see a couple of points. You should find that slope. This slope should be much bigger, okay? Because this slope is newtons per meter. So this is how much force you have to apply to stretch this spring 1 entire meter, okay? So that's why these slopes are basically inverses of each other if you're kind of a math nerd genre. So they're basically inverses of each other. That's why one's really small and the other one's really big, okay? Now here's the whole point of this when you get to number 11. We want to find the area underneath this. Now here's another thing that you're going to see in a physics class. You all, up to this point in time, area has always been in something squared. Meter squared, inches squared, squirrel squared, something squared, okay? That's how you've always found area. And the reason that's been that way is because your dimensions have always been meters by meters, inches by inches, something like that, okay? Your dimensions have always been in a measurement of distance. And here's the leap of faith that you have to take. In physics, when we look at graphs, area also has meaning, but you don't know what the meaning is until you look at what's going to happen with units. So when you find this area of a triangle, 1/2 base times height. Easy peasy, lemon squeezy. Y'all done this before, right? So the 1/2 has no units. So you have a base in some number of meters. So this is why, and listen to me very carefully in terms of the instructions. You're going to go to your elongation and you're going to find whatever that elongation is, okay? I don't care what, you find your maximum elongation, okay? Whatever that number is. Then you're going to come up here and you're going to see where that crosses the line of best fit. Not the data point that's associated with it, okay? Not the data point that's associated with it. It's where it crosses the line of best fit. Now, if it happens to be the same thing, hey, cool, groovy, okay? But if it isn't, it's where it crosses the line of best fit. So the base of that triangle is going to be whatever that elongation is. You're going to come up, see where it crosses that line of best fit. That's going to be your height. Now, here's the leap of faith. You're going to have some number of meters times some number of newtons. Okay? So your units are just Newton meters. So it's going to be some number and then Newton meters. Okay, that's it. And don't flip out and go, oh, Mr. Burkamp, area is in something squared. We've been taught that. You're a warlock. No, it's just the units. The height of the triangle is in newtons, the base is in meters. And what you'll see later on, that represents a unit called a joule, which is a measure of work, which is also a measure of energy. Okay? So the area underneath that graph represents work. Now, let's talk about number 12. I'm going to take you to the moon. Now, here's where you would use masses. Now, if you use masses, if you put that 1 kilogram mass on there, what would happen to the elongation? Would it be the same, less, or more?
That's,
Much less. Keep that in mind, okay? I really hate that. Presentation time?
Yes.
Okay. These amazing people are from WSU Tech. What they're gonna do is talk you through the process of, is if you want to take this class for dual credit through WSU Tech. And you guys dropped the price this year, correct?
Yes.
It's what?
$199.
Yeah, basically $200.
Yeah.
Or rounded to 200. For a 5-hour class, it's a bargain, okay? So, all that you do, your spiel, you want me to pull up the PowerPoint?
Yes. Please.
God, you're so demanding. Gotta teach the kids, get your PowerPoint. Okay. I will leave this up to you.
Yeah. If you guys are wanting to sign up for the class, go ahead and take out your laptops. It's not a requirement that you sign up today, but definitely an option for you guys, if you're wanting to get that credit.
Let's see. Fine. Take this class for college credit and since I'll just have to retake it.
Okay, and then you'll just pull up, your Jumpstart account. If you have an account and you don't remember your password, just let me know and I can help you reset it.
If you don't have an account and you're gonna make one for the first time, you do need to know your social security number. So if you don't know that, we have a handout we can give you and you can sign up on your own time, whenever you can make an account.
Okay, and then you would click high school
can
student.
I get the handout?
Yep. Okay, you wanna go to the next?
Yeah.
Okay, so, all of the classes that are listed up there on the screen, those are general education classes, that you can take, and they'll transfer to any public college within the state. So, like the class that you're taking right now, that can be transferred to like K-State, WSU, KU, Butler, any of those colleges. The only thing you wanna keep in mind, is that they are a lot cheaper, as a high school student. So, like this class, we said is $199. If you go take it at like K-State right now, it's probably gonna be like $1,600. So saving quite a bit of money by taking it now in high
This is
school.
literally like, what, about $150 per credit hour?
Yeah, it's like 500.
Yeah,
And then you're gonna have to pay probably at least $150 for a textbook that you will never use.
yeah.
So,
Alright.
The only thing I will also say is that if you're planning to go to a university outside of the state, or wanting to go to a private university, probably talk to us, to make sure that this credit is transferable. Because we wouldn't want you to pay for a credit that can't transfer.
the other thing with physics, and this gets a little bit wonky. If you know you're going into engineering, you knew you were put on this earth to be an engineer, okay? This will not count as the calculus-based physics, okay? But if you're going into anything else, ancient German literature, whatever, okay? You need a science elective class, no matter what, okay? So you can take this as that elective, even if you're not going into physics, it will count as that. But if you know, absolutely know, you're gonna be an engineer, don't take it for dual credit. Now, in reality, what percentage of freshmen change their major? 95? Okay? Literally, about 95% of incoming freshmen change their major, probably within the first 2 weeks, okay? So, the other way to look at this is like, hey, you're gonna pay $200 for 5 credit hours. You're not out a lot, okay? But again, I'm just telling you, that's just something to keep in mind. All right, go ahead.
Take the shocker pathway.
Oh shoot, do you want to play it?
No.
Okay.
Take the.
Okay, go to the next slide. Okay. If you are signing up for the class today, at the top, or when you're on enrolled classes, do you already change yours to say Mays High School? Okay. Is yours say Mays South or Mays High School? You're gonna have to choose.
It's weird.
Mays.
This is Mays High School, but some of these kids go to Mays South.
Mhm.
Yeah.
So, we let them in. We took pity on them.
Okay, and then, we're gonna find physics at 7:30. There's gonna be more than one option, so just make sure that you find the one that says 7:30. It's on the first page?
Yeah.
Okay. Did you find it?
Yeah.
Okay. And then you'll hit submit. And then, on the left side, in the yellow, if you scroll back up, we're gonna go to parental consent. So, since you are not 18 yet, we just have to get permission, from your parent or guardian that you're gonna take the class. And then they're gonna be responsible for the payment, as well. So it's gonna send an email to them, you just wanna make sure that they check their email, so they can send that back to us. What's your last name?
D-U-I-E,
What's your first name?
Danny, just
What is it, I'm sorry?
Danny.
Danny.
There's a good chance I probably don't, because I think we have it on WSU.
Did you go to another high school?
No.
No, okay, no, I don't have one for you then.
Yeah.
So you would have to start the
Yeah.
application. Okay, next thing, I know you guys probably don't have them right now, for this class, I do need a copy of your transcript, so that I can show or see your math grades from last year, or your ACT scores if you have them. So you would upload that to the supporting documents tab. And that's gonna be on the left side as well. And then, you just wanna make sure it's a JPEG or a PDF file. If it's whatever the iPhone one is, starts with an H, I can't open that on my computer.
HTML.
And then, last thing is gonna be the FERPA form. So on the left side in the yellow, you'll click FERPA. And this just allows anybody, that might call me with questions, to have access to the information for your account. So if somebody's gonna help you pay for the class, you definitely wanna make sure that their name is on there.
And there's
So
gonna
you-
be a,
Sorry.
sorry, there's gonna be a section where you put in a code, you make up that code, okay? And whenever you make up that code, please share it with whatever parent or guardian is on that form. So when they give us a call asking for information, we ask for that code, they provide it to ensure they say who they are, and then we proceed with whatever they're needing.
Okay.
Okay, and then, up on the screen as well, if you guys wanna take a picture of this slide. The last day to enroll is September 6th. So you guys have a couple of weeks. That includes getting the parental consent signed and having a copy of your transcript. If I don't have those, I'll probably send you an email and a text, so just look out for that. And then we'll bring invoices out to the class as well as email you a copy, just like 2 weeks after that. And then your payment is due on September 30th. So you don't have to pay all at once. You can set up a payment plan by contacting the business office. But that first payment has to at least be by September 30th.
Also, you can't make a payment until you have that invoice, so don't try paying it beforehand, okay? Just wait for that invoice, and then after that, it'll have directions on how to pay.
Because there's a chance you may not get enrolled until the day the invoices go out, just depending on how much enrollment we have. Okay, the next slide. Okay, your responsibilities, if you sign up for the class, you are responsible for the payment. If you decide that you do not want the credit, you have until that September 6th date to drop the class. The only way to drop it is by emailing our high school team, so hsadmissions@wcutech.edu. That's also, that email's at the bottom of your Jumpstart account if you forget it. If you tell your teacher here that you wanna drop it, that's not officially dropping it with us.
Nope, I have nothing to do with this. I'm
You just gotta
teaching.
email us. And then making sure that you send in the transcript. Okay, some other options that you guys have available to you, in the left side, on the, in the yellow, those are our CTE academies, so, that's a half day coming out to our campus to take some of those classes, and you can get your associate's degree, or some of them like business, you can start towards 4-year. And then those are all free tuition. You're just responsible for any textbooks or tool costs. Unless you want to take general education classes, then you have to pay for those. The Shocker Academy on the other side, those are located at WC West, so just around the corner from here. And they're general education classes that we'll look at for transferring to a 4-year. So you can get about 35 credit hours knocked out towards that 4-year. And then it's only $99 per class for that. Oh,
Okay.
okay, and then if you guys want to take a picture of this screen just so you have our email in case you do have any questions. Do you guys have any questions right now?
Do they have to, or did you talk about that, where form that parents have, you have to fill out so the parents can
Oh,
access their grades and pay the money?
Perfect.
Yep.
Okay,
Yes.
Yeah.
because that's always a big sticking point.
Yes. If you guys have any questions, I'm also down in the MCA office every Monday. You
So,
guys have
yeah.
any questions right now? No? I feel like it's still too early on Monday.
Oh, yeah, try teaching.
Yeah,
Oh.
so we need parent consent, transcript to fully enroll you. If we don't have those, we can't enroll you. September 6th, so to either drop or enroll in the class. Can't message us in December saying you want to drop it because you didn't get a good grade. It's gonna be too late by then. So yeah, just making sure.
Or the other side of it is if you, between now and then, you do decide, oh, I do need the class for credit, don't come to me in December and go, hey, Burkamp, I'd really like to still take this class. No. Okay,
Yeah.
Awesome.
Okay.
Okay,
we're good?
yes.
Thank you.
Awesome.
We'll be back in a couple hours.
Yeah, third block, I've got like a lunch,
Okay.
so.
What time?
Probably about noon.
Okay, I'll make a note. That's always tricky.
You're
Okay.
young, you know technology. I chisel into a stone.
Without this.
Okay. No, but that is, I mean, literally, you go to any major university, and it's gonna cost you literally like $150 a credit hour. So it's $200, it's a good deal. So, okay. Any questions on the lab? So again, this is how I view any situation, whether it's homework, labs, whatever, is that I view this as an opportunity to teach, to clarify anything that you all have. Now, there's 7, maybe 8 of you in this room. Y'all are successful academically, y'all are brilliant. I guarantee you, if you have a question, probably the vast majority of other people in the room still have the same question. So it's like, oh, man, I'm gonna look like an idiot if I ask that question. Okay? Ask the question. Okay? Ask the question. So, any questions? Going once? Twice? Yes.
I do have one. On number
Okay,
10,
God,
did,
you wait until I almost got to sold. Okay, go ahead.
did anyone else get a high number on number 10 for this slow?
You
I
should
got,
have, probably
Yeah.
around 70 or 80, depending
Oh.
upon
I
the
got
spring.
78.4.
Yeah, there you go.
I got 60.
Yeah,
I got
this is the
63.
inverse
It just
of that-
looked
of that
really
first
high to
number.
me for some reason.
No, you're fine, you're fine.
When you do like Newton's like times of meters, isn't it like Newton's like kilograms, meters over second squared?
If that, just
So-
don't,
What is it meter squared?
just leave it as,
It's just for meters.
just
Okay.
do that. Do not make it complicated. You can, but I'm just gonna become annoyed. Just, I'll tell you when to make it complicated, this is not the time. Okay, anything else? Going once, going twice, so here's the story. So the staple hanging up there, you will hand in your papers into that top tray where there's the Pink Panthers since I've had since 1994. And so that's where you're gonna hand stuff in. Now, I'm gonna point this out, because I feel like I have to. When you hand in papers, okay, I don't want this action going on, okay? When you staple them together, take a second, make sure the edges line up,
Full
and
second?
staple it in the top
Yes,
left
full
corner.
second.
I've never had to do that until the past 3 or 4 years. It's like, they've taught you how to like answer long questions wrongly, but didn't teach you how to staple, okay? Stapling, it's a skill, all right? So, take a second,
Chart.
make sure all the
Gra-
edges are
sorry.
lined up,
Graph on front,
and then,
graph on top.
graph on the bottom. Maybe because your name's on the purple sheet, that's,
Well, I put my name on both, but yeah.
okay. Well, you know, purple sheet on the
For
purple
when
sheet.
I undoubtedly leave something behind, they know. No, this is the clown this belongs to.
Okay. All right, we're good? Okay, so stop yonder camera.